Okay, let's dive into this. Welcome to this explainer. Today, we are absolutely going to unlock the secrets to mastering the microservices technical interview. Look, if you've ever faced a panel of senior engineers dissecting your system design choices, you already know that microservices architecture is literally the undisputed heavyweight champion of interview topics right now. So, today, we're building an expert guide that won't just give you canned answers. No, we're going to help you truly understand the concepts using simple, everyday analogies so you can walk into that next interview with total confidence.
Here is our agenda for the day. First, the architecture challenge. Second, 5 key features. Third, inter-service communication. And finally, number 4, monolith versus SOA versus microservices.
All right, starting with section 1, the architecture challenge.
Imagine you are right there in the interview hot seat, and they ask you to map out a request flow for something like a citizen and vaccination center app. Well, it all starts with the client requesting access, right? But the really critical piece here is step 2, the API gateway. I want you to think of the API gateway as the front desk receptionist of a massive corporate building. Instead of duplicating security checks at every single department store, which would be a nightmare, the receptionist checks your ID at the front, authenticates you, and then intelligently directs traffic to the exact department you need. It handles all that security up front, so your individual microservices just don't have to worry about it.
But see, that setup leads us straight into a massive architectural headache. A senior engineer will absolutely look at you and ask, so, how do microservices actually find each other when cloud IP addresses constantly change? Because in a dynamic cloud environment, port numbers and IP addresses are constantly shifting. You simply cannot hardcode URLs into your services. Why? Because the very second an instance reboots, the address changes, and boom, your connection breaks.
And here is your winning answer, service discovery. In our source materials example, they use Netflix Eureka. Think of Eureka like a dynamic corporate directory. In our metaphorical building, employees, or, microservices, are constantly switching desks and getting new phone numbers. You can't memorize their numbers. Instead, you consult the living phone book. So when your API gateway needs to send a request, it just asks the service discovery registry, hey, where exactly is the citizen service sitting right now? The registry provides the most up-to-date real-time IP address, making sure the connection is made perfectly without a single hard-coded port.
Moving right along to section 2, 5 key features. To really grasp why the entire tech industry shifted to this model, we need to quickly look at 5 core pillars that ensure loose coupling and high cohesion. First up, it breaks applications into smaller, independently deployable services. Second, the decentralization of data management, meaning every service owns its own database. Third, operating as a black box. Fourth, decoupling security to the API gateway, like we just talked about. And fifth, offering incredible Polyglot architecture support. Let's actually zoom in on a couple of these because they're huge for interviews.
If an interviewer starts grilling you about team scaling, Polyglot architecture is absolutely your golden talking point. Polyglot basically means different microservices within the exact same application can be built using completely different programming languages. Let's say you have a strict 1-month deadline, right? You've got 5 engineers who write Java and 5 who write Python. Now, in an old-school monolithic app, you'd be totally stuck. But with microservices, the Java team builds the citizen service, the Python team builds the vaccination center, and they still seamlessly work together. It's a lifesaver. So the next big thing is how these services interact without stepping on each other's toes. That brings us to the black box concept. Basically, the vaccination center doesn't need to know, and honestly doesn't even want to know, what complex tech stack the citizen service is built on. All that internal complexity is entirely hidden. It just asks for data and gets data back. It's a complete black box. This means teams can innovate totally independently. Like one team can upgrade to Java 11 while the other stays on Java 8, and there is zero disruption. All right, section 3, inter-service communication styles. Now we're getting to the climax of the interview. It's one thing to have isolated black boxes, right? But the system only works if they can actually talk to each other. When an interviewer leans in and asks, if microservices are completely independent, how do they coordinate complex tasks? They are specifically testing whether you understand when to use synchronous versus asynchronous communication. So let's break that down.
The best way to think about it is this. Synchronous communication is exactly like a real-time phone call. The client makes a request and literally waits on the line for a response. If the other person doesn't answer, the whole process just stalls out. On the flip side, asynchronous communication is like leaving a voicemail or, say, dropping off a letter. The client sends a message and immediately goes right back to work without waiting around for a reply.
Let's look a bit closer at synchronous communication. This typically uses HTTP protocols via REST APIs. So when do you actually use this? Well, you use it when the user interface absolutely needs a collective response right away. For example, if a user clicks on a specific vaccination center on your app, the UI needs to display both the center's details and the number of citizens registered there. The thread literally has to block or wait for the citizen service to reply so you can show the user the complete picture immediately. No waiting around.
But what about tasks the user doesn't necessarily need to see right away? That is exactly where asynchronous communication shines, usually using tools like Apache Kafka or RabbitMQ. A perfect example here is a background logging service. As the system architect, you obviously want every single request logged for tracing, but you absolutely do not want to slow down the user's experience by making the main application wait for the logging database to confirm a save. That would be terrible for performance.
Instead, this creates a beautiful fire-and-forget asynchronous flow. Step 1, the producer generates a logging message. Step 2, it fires it off to a broker on a defined queue, which we call a topic. Step 3, the broker essentially just says, "Got it," and the producer immediately goes back to serving the user. Finally, step 4, the consumer, which in this case is our logging service, subscribes to that topic and processes the logs at its own pace. The crazy part? The producer and consumer don't even know each other exist. They literally only interact through the broker.
Okay, final stretch. Section 4, Monolith versus SOA versus Microservices. Let's see how all of this builds into the ultimate interview trap question. This is the exact pitfall that catches so many experienced engineers completely off guard. The interviewer casually asks, "So, how did you implement your microservice?" And you proudly answer, "Well, I built 2 applications and they interact with each other through a REST API." Boom. The interviewer might literally reject you on the spot. Why? Because simply having 2 applications talk to each other does not automatically make it a microservice architecture. Actually, that could very easily just be service-oriented architecture, or SOA.
To really ace this, you have to nail the fundamental differences between these 3. A monolithic architecture is a big, tightly assembled container where all data is shared completely. Everyone is in the same pool. SOA, service-oriented architecture, is a collection of coordinating services, but crucially, it shares and reuses data heavily. For instance, in an SOA, both your citizen app and your vaccination app might share a single Google Maps API integration to fetch location data, reusing the same underlying code and data structures. But microservices, they are small, autonomous, and completely independent.
And that brings us to the ultimate golden rule of microservices. Sharing data is a complete no. Loose coupling and absolutely zero data sharing are the undeniable hallmarks of a true microservice architecture. Listen, even if 2 services need similar logic, they still do not share code or databases. They maintain total, complete isolation. If you are sharing data just to avoid redundancy, you are building an SOA, not microservices. Keep that straight and you'll impress any interviewer. And this leaves us with a really critical question to ponder. When you sit down to design your next system, or when you sit down in that interview chair, will you be building true autonomous microservices, or will you end up designing a service-oriented monolith in disguise? Understanding these core principles, from strict data isolation to asynchronous communication, is exactly what separates the novices from the true architects. Thanks for joining me on this explainer. Keep designing smart, and I'll catch you in the next one.